the bay wrong God. Tell the paparazzi get the lens robbed. Got the window down, top don't lie. Got the hazard on the gun. You can catch me.
Math morning. Mr. Dirk is back at it again. Let's do some functions as rules and tables.
Let's jump right in. So we've got two important words here. We have domain and range. What you want to do is pause the video, copy these down. Alright, so the domain, the set containing all inputs, x values, independent variable. These are all synonyms. I might say inputs one day, I might say x values one day, independent variable the other day. They all mean the same exact thing. The range, this is conversely related to the domain. So it's the set containing all of the outputs, the y values, the dependent variable. I should have put a comma right there. So you put something in is the domain, you get something out, it is the range. An example, let's see, I take a number, if I multiply it by 3 and then I add 4 to it, so whatever I put in, that's my domain. Alright, whatever I get out, I do these things to it, that's going to be my range. The input, the output. The domain, the range. The x value, the y value. Here's an example down here. So the input, these are all of the possible things you can start with. The output, these are everything that comes out at the end. So my range, let me start with the domain. Sorry, domain's over here. The domain, these are all of the inputs. So what can I do? These 4 numbers up here. When you write the domain, you want to use a curly bracket. That is the official name, curly bracket. So you have a 10, 12, 13, and 17. Then close it off with a curly bracket. So the domain is everything that is the input, these 4 numbers. The range, conversely, is the output. So these 4 numbers here. Again, you want to use the curly brackets. So you have 19.99. You have 23.99. 25.99 and 33.98. Close them off with the curly bracket. Again, we have the range, that is the output. The domain is the input. And one more thing, the input, that's going to be your x values. The output is your y. Make sure you put that there. Okay. Alright, we're back with another word, function. So pause the video, write this down. So a function, it's a pairing such that each input is paired with exactly one output. In simpler words, for every one input, there is only one output. So here's an example. We've got 3 players. These are all basketball players. We'll write players. And these are their teams. Alright, so we know LeBron, he plays for the Cavaliers. Kyrie, he plays for the Celtics. That's him over there. And Steph Curry, he plays for the Warriors. Alright, so this is a function. We have the inputs right here and the outputs over here. And for every one input, there's only one output. LeBron only plays for the Cavaliers. Kyrie only plays for the Celtics. And Steph only plays for the Warriors. So this right here, this would be a function. But wait, let's mix it up. So let me get my eraser. I'm going to erase some stuff. Eraser. I'm erasing. Bam. Oop, not erasing. Eraser. Eraser. Got it. Alright, we're erasing. Let me get my pen back. Okay. So let's imagine. Okay, LeBron, he plays for the... Who does he play for? The Cavaliers. Let's say he missed Kyrie so much. He said, let me play for the Celtics too. Right? I want to play for both teams. Kyrie, he's still on the Celtics, and Steph, he's still on the Warriors. Is this a function? Well, the definition says for every one input, there's only one output. If LeBron is the input, the player, he has two outputs, right? It's not possible to play for the Celtics and the Cavaliers at the same time, right? It's impossible. So if it was this, oh my, what happened? This would be no function or not a function, because you have one input and there's two outputs. LeBron cannot play for the Celtics and Cavaliers. It's impossible. All right, let's try this with some numbers. Let's move over, Kyrie. All right, so we've got 4, 8, 11, 0, 5, 9. All right, let's try it out. Let's say the input, these are the inputs, those are the outputs. And let's say 4 went to 5, 11 went to 0, and 8 went to 9. Does every one input have only one output? Yes, right? So this is yes, it is a function. And you might not have space for this on your paper. Don't worry about writing this part down. We'll do some more examples after. But yes, this right here, this is a function. All right, let's try again. Let's get my old eraser out. So, let's say 4 goes to 0. 8 goes to, let's say 8 goes to 5 and 9. And 11 goes to 9. Is this a function? Well, 4 has one output, it's 0. 11 has one output, that's 8. It's 9. And 8 has two outputs, right? 8 has 5 and 9. If one input has two outputs, this is not a function. Not a function. All right, one more. Let's see here. I'm going to give you the hardest one now. The hardest one now. All right, you ready? Let's see here. What if 4 went to 0, 8 went to 0, and 11 went to 0? Your initial thought might be, okay, no way, it's not a function. But let's think about it. 4 has only one output, it's 0, right? 8 has one output, it's just 0. And 11 has only one output, which is 0. The inputs don't have two outputs. Every input has the same one. It's a difference. So if I was going to write the domain and range, right? The domain, these are all your inputs, squiggly line. You have 4, 8, 11. The range, these are all possible outputs. Well, every output is 0. So I just put 0 on there. So this is a function. Remember the rule, every input has one output. Just check. 4, one output. 0. 8, one output. 11, one output. All right, here are some more examples. So tell whether each pairing is a function and identify the domain and range. Well, let's do the domain and range first. So this one right here, you're going to draw this picture. So the input is a domain. I draw my curly brackets. We've got 4, 5, and 9. The range, draw the old curly brackets. 0, 1, 2, 3. Alright, so let's see. Does every input have one output? 4 has 0, so that one would be good. 9 has 3, that one would be good. But 5 has two outputs, 1 and 2. Because this part right here has two outputs, it is not a function. This one over here, the inputs. So let's do domain and range again. The domain are the inputs. Draw the curly bracket. We have 4, 5, 6, 9. 4, 5, 6, 9. The range, so 10, 10, 10, 10. These are all the same. So for the range, I don't need to write them all. I'll just write 10. So let's see, is it a function? This input 4 has only one output. The input 5 has one output. The input 6 has one output. And the input 9 has one output. So yes, every input has one output. So this is, yes, a function. A last one. All right, we got the domain. Everything is 10, right? All the inputs are 10, 10, 10, 10, 10. So squiggly bracket, 10. How about that range? We got 4, 5, 6, 9. 4, 5, 6, 9er. All right, so let's see. Well, the input 10, it's really just one input. 10 could be 4, it could be 5, it could be 6, it could be 9, right? So this one input 10 has 4 different outputs. So this is not a function. So make a table for the function. Identify the range of the function. So this is an equation, y equals 1/2 x plus 7. That's also the rule. And they gave you the domain. All right, so we need to find the range and make a table. So we make a table. We've got x and y. Boop, boop. All right, that should give us 4 spots. The domain, those are the x values, right? So for the x's, I'm going to put 2, 6, 10. Oh, I didn't do it right. 12. So those are the domain, the input, the independent variable. And now we need to find the outputs. So how do we do that? Well, we have y equals 1/2. Instead of x, I put in the domain values, the inputs, 2, and it's plus 7. If I simplify that, 1/2 times 2 is a 1 plus 7, and that equals 8. So the input of 2 gives you the output of 8. The next number I'll do will be 6. So y equals 1/2 times 6 plus 7. Y equals 1/2 times 6. Let's see here. That's 3 plus 7, and that equals 10. All right. The next one I'll do, y equals 1/2 times 10 times 10 plus 7. All right. Y equals 1/2 times 10 is 5 plus 7, and that equals 12. So I put 12 right there. And the last one, y equals 1/2 times 12 plus 7. Y equals 1/2 times 12 is 6 plus 7. 6 plus 7, that equals 13? 13? 13. Yep, 13. So bam, I put it right there. So there's my table. That's all done. Now I need to find the range. It gave me the domain, all right? So my range, I'll write it over here, are the possible inputs. So what did we, the outputs, all the possible outputs. What did we get? We got 8, 10, 12, and 13. So there's the range, that's the outputs. The inputs are the domain up there, and here's our table. Now on this one, we're going to write a rule for the function, right? They give you the input, all these numbers, and the output, and we need to find out how the input becomes the output. And we're going to be in the form of y equals something. So we look at our input and find out what do we do to get to the output. So I normally look at input and then, the 4 operations, add, subtract, multiply, divide. I know 4 times 2 equals 8, right? So if I did 4 times 2 equals 8. Well, what about 7 times 2? Does that equal 11? No. 10 times 2 equals 14? No. 13 times 2 equals 17? No. So it can't be times 2. Alright, what about 4 plus 4 equals 8? Let me try. Plus 4 equals 8. Well, 7 plus 4 is 11. 10 plus 4 is 14. and 13 plus 4 is 17. So it looks like plus 4 works. So this equation, the rule is going to be, we take the input, which is x, and we add 4. So we have an equation, or the rule, describing the relationship of the input and the output. So now I want you to try these two by yourself. The first one, tell whether the pairing is a function and then identify the domain and range. The next one, find a rule for the following function. Try them by yourself and then come back. And in the meantime, here's some cats on an exercise ball thing. All right, so let's go over these. Okay, get rid of the cats. So, tell whether the pairing is a function and then identify the domain and range. All right, so the rule of a function, does one input have one output? So 1 has only one output. 0 has one output. And 6 has one output. So yes, it is a function. And the domain are all the input values, 1, 0, and 6. And the range are the output values, 3 and 5. There you go. Find the rule for the following function. Alright, so I'm looking at this. I look at my inputs. How do I get from 3 to 0? How do I get from 5 to 2? How do I get from 7 to 4? From 9 to 6? Well, it looks like they're all being subtracted by 3. 3 minus 3 is 0. 5 minus 3 is 2. 7 minus 3 is 4. 9 minus 3 is 6. So the output y equals the input x minus 3. There you go. So that's it for this lesson. Good luck with the packet. Good luck on the quiz. You got this. Before we go, I want to show you a video of a vending machine, because vending machines are great examples of functions. If you think about it, you put in one number and you only get one snack. One input, one output. So let me show you a video of a pretty cool vending machine.